Okay, so we continue with the heat transfer and we are on thermal expansion in liquids. So as I said that the expansion of liquid is similar to the expansion of solids. Liquids are going to also expand. In fact, the expansion in liquids will be much more than that in solids. Now only, and also we understood that water has got this anomalous behavior that between 0 to 4 degrees Celsius it is going to do ulta. So instead of from 0 to 4 when I am heating it should expand, but nahi, expand nahi hota, contract hota hai. Or from 4 to 0 when I am cooling it, instead of contracting it expands. So that is the anomalous behavior of water. Now we are seeing the cubical expansion in liquid. So in this case there is an experiment over here. What we do is we are going to take a particular bottle. This empty bottle will be there, and this empty bottle over here is going to be filled up with water up to a particular level. You are going to place a cork on top of it, which will be having one particular hole, which will be having a straw. So you'll be having a straw which will be placed like this. Now you are going to fill up the water in it, and you are going to fill the water up to this certain point. So this is what is going to be up to. So this is the condition, and then you are going to place it in a brick over here. If you are getting 2 bricks over here, and then you are going to put the flame over here. So this is going to be the burner which is going to heat up this particular jar. Okay, so this particular bottle is going to be heated up in this manner. So what we have is that when we see this is going to be the point at which the water level was initially. So this is the initial level A, and when I heat this up, after some time, after 5 minutes or so, when I check this thing, I will find that the level would have gone to a level B over here. Okay, so this particular increase in the level will be seen, which proves that the water inside has expanded due to the heat. So very easy kind of a thing. There is nothing much over here. In fact, there is one more thing what could happen over here, but anyway, it's not for your 8th standard part. But anyway, I'll just give you the information. What will actually happen is that when I start heating this thing, first the level will go up to a point here. It will decrease. The level will decrease first. You know why? Because firstly, when I am heating it, the bottle over here is going to expand. And the bottle expands, automatically the level of the water will go down. Okay, क्योंकि bottle का capacity बढ़ गया, expand हो तो water का capacity बढ़ गया bottle का, इसीलिए it would go down. But then subsequently, when you keep on heating it, it expands and it reaches to this level. So actual increase is from here to here, but we see the increase only from A to B. We see the increase only A to B because when it goes down, it is the expansion of the bottle which has taken place. Because जब हम heat करेंगे, तो bottle also is going to get heated up first, and when the bottle gets heated up, it is going to expand the same way as the water. So that's why it is going to go down first and then it will rise up. Anyway, it is just for your information. There is nothing connected to the textbook. So take an empty bottle with a tight fitting cork having a hole drilled in its middle, a drinking straw, 2 bricks, a wire gauge and a burner. Fill the bottle completely with water and add a few drops of ink in it to make it colored for easy contrast. So basically you are not taking into direct only water, you are going to make it red color, blue color so that you can easily see it. Fix the cork in the top of the bottle and pass a drinking straw through the cork. Put some molten wax around the hole so as to avoid the leakage of the water. So you are going to seal this thing, you seal this part also so that there is no leakage of water vapor which is going to come there. Pour some more water into the drinking straw so that the water level in the straw can be seen. Mark the water level in the straw as shown in the figure. Place the bottle on the wire gauge kept over the 2 bricks as shown in the figure. Heat the bottle using the burner. Look at the level of the water in the straw. You will notice that as the water is heated more and more, the level of the water in the drinking straw rises. This shows that water expands on heating. So that's exactly what is going to happen when you start. The initial level was this much. When you start heating it, it will go up, up, up and reach this particular point after some time. So that is nothing but the expansion of water or any particular liquid. So this shows that liquid also expands on heating. Do you know when a liquid contained in a vessel is heated, first the vessel will get heated, so it will expand, due to which the liquid level of the liquid will fall. Good, they are given in the did you know, okay, I didn't knew that it was given in the do you know part of it. So this is exactly what I explained to you. So when you are going to heat this thing, initially this particular bottle is going to get heated, and due to the heat of this, it is going to expand, and the bottle, when it expands, the water level will go down. When it goes down, so पहले A से वो C पे आएगा, okay? From A, the water level will come to C, and then it is going to come from C to B. So final level will be C, initial level will be A, but in between, if you constantly monitor it, you will find that the water level has gone below the A, and then it shoots up. This is because the expansion of the vessel is going to be shown from A to C. A to C will be the expansion of the vessel. So when a liquid contained in a vessel is heated, first the vessel will get the heat, so it will expand, due to which the level in the liquid will fall. Thereafter, when the heat reaches the liquid, it will expand, so the level of the liquid will rise. Since liquid expands more than solids, the liquid level rise above its initial level. Thus, the real expansion of the liquid is more than the observed expansion. So, real expansion is from C to B, whereas observed expansion is only from A to B. So the real expansion is more than the observable expansion. So that was an important do you know. Now explanation of the thermal expansion of liquid by molecular motion. In a liquid, the molecules are free to move anywhere within the liquid. When a liquid is heated, the average kinetic energy of its molecules increase. As a result, the molecule begins to move more vigorously, thereby increasing the intermolecular separation. Thus, the liquid expands on heating. So, very simple thing. The liquid, when you are heating it up, automatically the average kinetic energy is going to increase. With the increase in the kinetic energy, there will be a separation which is going to increase. More the separation, automatically more the expansion, or you can say it gives rise to the liquid expansion. Factors affecting cubical expansion of liquid. Now, factors affecting the cubical expansion is the same as the factor affecting the cubical expansion of solids. So, first thing is the initial volume of the liquid. So, first is the cubical expansion of liquid depends on the following three factors. Original volume of the liquid. Larger the volume of the liquid taken, more is the increase in its volume on heating. So, yes, again the same thing. Initial volume of the liquid will be the first point. Second point is, of course, the same thing, rise in temperature. Okay, we exactly saw the same thing in solids also. So there is no change over here. In fact, even the coefficient of linear expansion, coefficient of cubical expansion is going to be coming into play over here. So it's exactly the same as what is in solids. So yes, so rise in temperature, greater the rise in temperature of the liquid, more is the increase in the volume. So जितना ज़्यादा हम लोग heat करेंगे उसको, जितना ज़्यादा temperature उसका करेंगे, उतना expansion ज़्यादा होगा. So the more the temperature, more the expansion. And finally, nature of the liquid. Equal volumes of different liquids, when heated to a same temperature, undergo different increase in their volume. So similar to that of the solids. Solids also we know that iron is going to expand less than copper. Right, so similarly, different kind of liquids are going to be expanding in different manner. So the expansion of the liquid is not same for all the liquids. They are different for different liquids. So that is the third point, that is nature of liquid. Finally, if V0 is the volume of the liquid at 0 degree Celsius, so we have again the same thing, Vt minus V0 is equals to V0 gamma T. Okay, where V0 is the volume of the liquid at 0 degree Celsius, Vt is the volume of the liquid at T degree Celsius, T is the temperature, and gamma is the coefficient of cubical expansion of liquid. So, if V0 is the volume of the liquid at 0 degree Celsius, Vt is the volume of the liquid at T degree Celsius, then increase in volume of the liquid is given as Vt minus V0 is equals to V0 gamma T, where gamma is the coefficient of cubical expansion of liquid. Now we are going to see that how we are having the different kind of liquids having different cubical expansion. So we are going to kind of experiment to prove this particular thing. So different liquids have different cubical expansion. Experimentally, it is observed that equal volumes of different liquids when heated to the same temperature expand by different amounts. This can be easily demonstrated by the following activity. So you got a small activity. You take a big trough of water. In that particular trough of water, you're going to place 3 jars. And this 3, we are going to take the 3 round bottom flasks. One containing water, other containing kerosene. Next is alcohol, and fourth is benzene. So these are the 4 things what you are having, and you are going to make them almost like this. कि हर एक का level जो है वो level A तक है. Okay, we are considering that all of them are till level A. So all of them are filled up to level A. So benzene भी इतना, alcohol भी इतना, water भी इतना, kerosene भी इतना, ऐसे करके 3-4 flask का दे. The trough of water is going to be heated up so that equal heat is being given to all the 4 containers at the same time. Okay, so we are placing it in a trough of water because we are going to heat the water now. When we heat the water, so equal amount of heat is given to all the 4 different jars. You will find, of course, that water जो है उसका expansion कम होगा, kerosene का थोड़ा ज़्यादा होगा, alcohol का और ज़्यादा होगा, benzene का सबसे ज़्यादा होगा. So you will find that the expansion of the liquid will be more in case of benzene and least in case of water out of this 4. So 4 identical glass bottles, each fitted with a narrow glass tube through a cork at its mouth. Fill them with the same level with different liquids, say water, kerosene, alcohol and benzene. Place them in a common water bath containing the boiling water as shown. After some time, you will notice that the different liquids rise to different levels. Benzene expands most, then alcohol and kerosene. Water expands the least. The table given below gives the coefficient of cubical expansion of some of the common liquids. Mercury is 1.8 into 10 to minus 4 per degree Celsius. Paraffin oil 7.64. Turpentine 10 into 10 to minus 4. Ethyl alcohol 10.9 into 10 to minus 4. And benzene is 12.5 into 10 to minus 4. You need not learn these values from the table. Okay, जरूरत नहीं है. I don't think it is required to learn this particular values. Water does not have a fixed coefficient of cubical expansion. Its value varies with rise in temperature. So with the rise in temperature, the cubical expansion is also going to change because of the anomalous behavior. That's the reason they are not given the cubical expansion of coefficient of cubical expansion of water. The applications of thermal expansion in liquids. Thermal expansion in liquids is used in the working of mercury thermometer. We have read that the mercury thermometer contains of a capillary tube with one end closed and the cylindrical bulb at the other end. The bulb is filled with mercury. Mercury is a shiny liquid, so its level can be easily read in the seen easily in the capillary tube. When the bulb of the thermometer is kept in contact with the hot body, mercury expands. The level of the mercury rises in the capillary tube. The tube is graduated to read the temperature. For each degree rise in temperature, the mercury expands by the same volume, so the calibration of thermometer becomes easier. So this is basically about the use of the cubical expansion of liquids in the production or in the making of a thermometer. So we know very well, if you take a thermometer, जो घर में normal रहता ही है कि there is a mercury bulb at the bottom. So the thermometer looks like this, if anybody has not seen it properly. The thermometer looks like this, where this particular part is the bulb which is filled with mercury. So this particular bulb is filled with mercury, and there is a very thin capillary tube over here, very thin capillary tube, and then there are markings over here 0, 10, 20, 30, 40 और यहाँ पे 100. Okay, इस तरह से रहता है. Of course, if it is a thermometer for body temperature, then it will not start from 0. It will start from somewhere near 35 degrees Celsius, or in case of Fahrenheit, it will be something in 95 के आसपास में, and the maximum will be only 110 के आसपास में Fahrenheit. So what will happen is that when this particular mercury is heated, suppose you are putting it into hot water. So what will happen? The mercury will get heated up, and when it gets heated, it is going to expand. And when it expands, so जो level यहाँ तक का था, वो expansion के हिसाब से it is going to rise up. So that rising up will show that what is the temperature of the water. So this is how the mercury thermometer is going to work. So, and mercury is used. Why is mercury used? Is because firstly the mercury is a very shiny liquid, so it can easily be seen in that particular capillary. So capillary mein mercury can be easily seen. That is one reason to see the mercury. Also mercury is purely available, pure form of mercury available very easily. So that's why it is easier to use mercury. Plus the expansion of mercury is very high, which can easily be noted. When you want to see the difference in the temperature quite precisely. So mercury will give you a bigger value between the two digits, like 10 or 20 के बीच में काफी सारे distance रहेगा. So you know that exactly it is 22 or 23 or 25. So it is easier to mark that thing. So that was about the application of thermal expansion of liquids in daily life. We now move over to the last part, that is thermal expansion in gases. Gases also expand when they are heated. Gases expand much more than the liquids and solids. Like liquids, gas do not have a definite shape, so they also have only the cubical expansion. So gases, as we know, the intermolecular space is very, very high, the force of attraction is very, very low. That's why heating it, the average kinetic energy just shoots up like anything, and that's why the gases are just going to go in a very, very random manner. Hence, the expansion in case of the gases is much, much, much higher than the solids and liquids. And also, because the gases do not have a definite shape or a size, that's why the only thing what they can have is a cubical expansion, that is volumetric expansion. There cannot be any linear or superficial expansion in gases. Thermal expansion of gas can be demonstrated by the following simple activity. So it is a simple activity what they have taken up. So this particular expansion what they want to show. So the expansion is so simple that the method is very simple. You take a bottle. So this bottle is empty. There is a completely empty bottle. And to this empty bottle you are going to place a balloon. Okay, the balloon is going to be placed over here like this, which is completely deflated. So there is a balloon over here. And then you are going to start heating this thing. So when you heat this, the air inside over here is going to expand, and accordingly the balloon is going to slightly blow up. So why would it blow up? Because air has expanded over here, because it's completely filled, sealed tight, it is not allowing any air to escape out. So whatever is the air inside is going to expand, and that expansion is seen as the balloon getting inflated. So take an empty bottle. Actually the empty bottle contains air. Attach a rubber balloon to the neck as shown in the figure. Initially the balloon is deflated. Place the bottle in the water bath containing boiling water. So yeah, you are not going to heat it directly because the glass may break. So that's why you are going to put it in the water bath. So you are going to place it in the water bath which is having boiling water inside, so that the heat is transferred directly from the boiling water into the container. So place the bottle in a water bath containing boiling water which heats the air contained in the bottle. After some time you will notice that the balloon gets inflated as shown in the figure 1.66.14. This shows that on heating, the air enclosed in the bottle expands and fills the balloon. Hence, the balloon gets inflated, thus air expands on heating. Do you know? A gas is heated by keeping either its volume or pressure constant. In both cases, the expansion is same. Increase in the pressure when volume is kept constant, or increase in volume when pressure is kept constant are same. So see it is this way, I can have the expansion of any particular air or gases in such a way that either I am going to have an increase in volume or I am going to have an increase in pressure. Because the gas, if it is expanding in a particular container which cannot expand. So suppose यहाँ पे balloon नहीं होता और balloon के बदले अगर एक ball होता which is already filled up, okay, or a glass thing which is there, then what will happen? Suppose this is just a glass cap, or cap is there. What will happen inside over here? The pressure inside this particular bottle will increase. So, in this case, what is happening? The volume of the air is remaining the same, but the pressure is increasing. But if I put a balloon over here, then the pressure inside the bay remaining the same, but the volume is increasing. So, we can have either of the two. Either we can have the volume increasing on heating with pressure remaining the same, or we can have the pressure increasing with the volume remaining the same. That is what is the meaning of the do you know, which is here, that a gas is heated by keeping either its volume or pressure constant. Either I am going to keep the volume constant or the pressure constant. In both cases, the expansion is same. In both the cases, expansion is going to be the same. That is, increase in pressure when volume is kept constant, or increase in volume when pressure is kept constant, are the same. Expansion or thermal expansion in gases by molecular motion. In a gas, molecules are has more intermolecular spacing between them, amongst them. On heating, the average kinetic energy of the molecules of the gas increases, and they being to move more violently in all available space available to them for motion. As a result, the intermolecular separation further increases, so they expand. So this I just explained you that. So when you are heating it, because the intermolecular space is extremely high, so force of attraction is low. So as soon as you heat it, the kinetic energy, average kinetic energy increases, so they move out more randomly, and accordingly it will take the whole space available to them. Now, variation of density with temperature. Now this is something important. We know that what is density. We had learned about density in the previous chapter, that density is mass upon volume. Okay, what we have is density is equals to mass upon volume. Now you can see over here that when I am going to heat it, when I am going to heat something, my mass is going to remain the same, but my volume is going to increase. If my volume increases, my density automatically decreases. That is what we are learning here. So when I am heating any particular kind of a substance, on heating, what is going to happen is its volume is going to increase. If the volume increases but the mass remains the same, so the density decreases. So when a substance is heated, its volume increases while its mass remains the same. Therefore, the density of the substance, being the ratio of the mass to its volume, decreases with the increase in temperature. In case of solids, when the temperature increases, increase in volume is very small, and therefore the decrease in the density is not appreciable. Yeah, because we know very well that the coefficient of linear expansion is so small. So इसलिए volume इतना ज़्यादा difference नहीं होता है. Because the difference is not much, that's why the density in case of solid being heated is not appreciably changed. It is almost going to remain the same. But in case of liquid and gases, as temperature increases, volume increases by an appreciable amount, and therefore decrease in the density is quite considerable. Of course, the exception again is water. Why there will be a problem with the water? Because water, when I am going to heat it from 0 to 4, instead of increase in volume, there will be a decrease in volume. So the density will increase. So that's what we are saying. Water contracts on heating from 0 degrees to 4 degrees Celsius. So the density of water increases on heating it from 0 degrees to 4 degrees Celsius. On further heating above 4 degrees Celsius, the density of the water decreases. Thus, water has maximum density, that is 1000 kg per meter cube at 4 degrees Celsius. Because at 4 degrees Celsius, क्या होता है? So it is this way. 4 degrees पे water है, okay? Now, if I heat it, it is going to expand. क्योंकि 4 डिग्री के ऊपर जब भी हम लोग किसी भी चीज को हीट करते हैं तो एक्सपांड होने ही वाला है. सो वाटर आल्सो बिहेव्स नॉर्मली. सो 4 डिग्रीज पे उसको मैं हीट कर रहा हूँ 5 डिग्री 6 डिग्रीज पे, तो ऑटोमेटिकली वाटर इज एक्सपैंडिंग. वाटर एक्सपैंड्स, डेंसिटी डिक्रीजेस. सो ऑन हीटिंग वाटर अबव 4 डिग्रीज, डेंसिटी इज डिक्रीजिंग. Now let's cool it. So I am cooling the water from 4 degrees to 0 degrees. So when I am cooling it from 4 to 0 degrees, instead of contracting, it expands again. So because it is expanding, volume increasing, So density is decreasing. So that's the reason at 4 degrees the density is maximum. So the graph will be like this. If I make a graph over here with temperature and the density, so it is going to be like this. This is at 4 degrees Celsius. So the density over here, density at 4 degrees Celsius will be maximum. Whereas before it and after it, okay, 4 degrees के पहले भी density is down, 4 degree के बाद भी density is down. So maximum density, the water has got a maximum density that is 1000 grams per kg per meter cube at 4 degrees Celsius. Do you know, if an iron washer as shown in the figure is heated, its mass will remain unchanged, its internal diameter, its external diameter, its thickness and its volume all will increase, but its density will decrease. Yeah, of course the density will decrease. So everything is going to increase in case of washer. So if your washer क्या होता है, it is just a ring like thing, okay? तो उसको जब भी हीट करेंगे तो उसका thickness, length, breadth सब कुछ increase होगा. But उससे क्या हुआ? Volume increase हुआ तो density क्या हो गया? Decrease हो गया. So that is what they have written over here for the do you know. So it's quite a simple thing. It's quite obvious in fact. So in case of any particular solid material, if you are heating it, its length, breadth, height, everything increases, but accordingly the volume increases, but density decreases. Yeah, so this was about the chapter heat transfer. We have done it in 5 parts. We'll discuss the exercise in our normal Zoom class. So that's about the chapter. I don't think any numericals are not there in this chapter, so we don't have anything to do the numericals over here. But yeah, quite an easy chapter because as you know, the first part was the same as what was in method about the boiling and the evaporation, everything. So only the expansion part which is different over here. So yeah, good number of questions based on the give reason because of the practical examples which are given over here, or the applications, daily applications of thermal expansion. Okay, so this was about the chapter. Thank you.